Comparison of bending resistance of two optical fiber temperature sensors.
Fiber optic temperature sensor in the construction encounters such conditions. The size of the bending radius determines whether the product is suitable for application and easy to construct. Let's compare the bending resistance of two typical Shenzhen Akova, gallium arsenide, and fluorescent fiber optic temperature sensors. Gallium arsenide temperature sensor uses optical fiber diameter of 125 ohm, corresponding to the optical mode field is 60 to 0.5 ohm. Fluorescence temperature sensor uses optical fiber diameter of 330 ohm, corresponding to the optical mode field is 300 ohm. In a constant temperature environment, use 3 different radius winding bars, 30 mm, 20 mm, 10 mm. Simultaneously wrap the types of fiber optic sensor cables and observe their temperature changes. In practical applications, however, because the true temperature of the sensor probe location is unknown, in this case, we can judge the accuracy of the temperature measurement system by self-diagnostic results. Among them, the diagnostic results of gallium arsenide mainly depend on the interference value. The smaller the value, the better. The best value is below 30. It is unqualified if it exceeds 50, and temperature measurement above 300 fails. Light intensity is an auxiliary judgment indicator that represents the intensity of sensor light signals collected by the host, usually above 1. The fluorescent self-diagnosis results mainly depend on the diagnostic value. The smaller the grade, the better. 1 grade is the best, 2 grade qualified, 3 grade unqualified. For grade temperature measurement failure, LED value can be used as an auxiliary index. It represents the host to the sensor light signal intensity, usually more than 400, and 300 as a qualified standard. Next, I will demonstrate the effect of the bending radius on the performance of both sensors, as well as the performance diagnostic effect of the self-diagnostic value. Prior to the start, the 2 sensor probes have been placed in the already set up 60 degrees Celsius dry well furnace. First, a 30 mm radius round rod test was used. At this bending radius, gallium arsenide temperature is normal. The fluorescence temperature has been deterioration, about 1.5 degrees Celsius higher than the actual. Look at the self-diagnosis results. Gallium arsenide interference value is about 8.5. Light intensity is about 4, indicating that the temperature measurement performance is very good. The fluorescence diagnostic value jumps between 1 and 3 levels, and the LED value is about 307, indicating that the temperature is not qualified, is at a critical point, and the temperature measurement performance has been affected. Secondly, a 20 mm radius round rod test was used. At this bending radius, gallium arsenide temperature does not change. The fluorescence temperature has been severely degraded, about 3.5 degrees Celsius higher than the actual. Look at the self-diagnosis results. The gallium arsenide interference value is about 9.1, almost unaffected, and the actual temperature is accurate. The fluorescence diagnostic value has been reduced to the level for failure state. In actual use, in this case, it is necessary to stop the use and eliminate the fault of the sensor and the host. Finally, a 10 mm radius round rod test was used. At this bending radius, the temperature of gallium arsenide remains unchanged. The fluorescence temperature has exceeded the actual temperature by more than 6 degrees Celsius. Take a look at the self-diagnosis. The gallium arsenide interference value is about 9.4, and the light intensity is about 4, indicating that the temperature is still in the best condition. The fluorescence diagnostic value is still a level for failure state. The LED value dropped from more than 400 to 64, indicating that the light signal received by the host has been very weak. At this time, although there is a temperature value, but there is a possibility to stop showing the temperature at any time, so there is no point in monitoring at all. From the difference in the bending test demonstration of the 2 sensors, we can intuitively see that the gallium arsenide sensor has obvious advantages in terms of bending resistance. Moreover, through self-diagnosis, even without knowing the actual temperature at the probe position, it is possible to visually determine whether the temperature measurement performance is normal. That's all for today. Thanks for watching.